Okay, hey guys, so we're going to go over day 6 notes today, single replacement reactions. So single replacement reactions is actually a type of redox reaction. Okay, so it's where one element takes the place of another in a compound. And what's important about single replacement is that like replaces like. This is going to be the most important term or quote that you're going to use for single replacement and double replacement, which we'll talk about later on. Okay, so your general form for single replacement is that you are always going to have an A plus BC yields a B plus AC compound. Okay, and then the same thing here, D plus BC yields C plus BD, which is basically stating that if you have let's say that A is a metal, well, it's going to replace the metal that's in the compound. Okay, and so if D is a halogen, well, it's going to replace the halogen that's in your compound. Okay, they are going to switch places. Your identifying feature for a single replacement reaction is that you will always have one element and one compound on each side of the arrow. Okay, so notice how our general form here, we have one element, one compound, one element, one compound on either side of your equation. Okay, so your analogy is that a boy and a girl are dancing, but then another boy cuts in and dances with the girl, leaving the first boy alone. Okay, so that's what we see here. Boy and a girl are dancing, okay, but he wants to cut in. So B is going to go ahead and switch places with him so that guy can dance with the girl. Okay, or it can also be vice versa. So let's say that this is a girl. Well, she's going to switch places with the other girl. Okay, so it has to be the same. Like must replace like. Boy switches places with the boy. Okay, if it was a girl, the girl would switch places with the girl. Okay, so chemically, if you look at it from a chemical, as a chemistry standpoint, if you take a look at metal replacement, so we have sodium plus copper chloride. So sodium, that's your metal, it's going to replace the metal in this compound, which is copper. So you'll see as your product, sodium is now the one that's with copper, or sorry, with chlorine, and copper is the one that's all by itself. Okay, so if we take a look at a halogen replacement, fluorine is your halogen, so it's going to replace the other halogen in this compound, which is actually chlorine. So if you take a look, chlorine and fluorine switch places, and now fluorine is the one that's with potassium. Okay, now you do have exceptions. So just like in real life, okay, if I was with my boyfriend, well, I'm not always going to want to switch partners. I may want to keep dancing with my boyfriend. Okay, so we're going to have rules for reactions because, again, we are not always going to be switching partners. So we have to use the activity series. Okay, so your activity series is actually on the back of your periodic table. Okay, and this is what it looks like. So you can use the activity series to predict whether or not a certain reaction is going to occur. A specific metal can replace any metal listed below it that is in a compound. It cannot replace metal listed above it. Okay, so for example, copper atoms replace silver atoms in a solution of silver nitrate. Okay, however, if you place a silver wire in aqueous copper 2 nitrate, the silver atoms will not replace the copper. Silver is listed below copper in the activity series, so no reaction is going to take place. The letters NR, or no reaction, are commonly used to indicate that a reaction has not occurred. So this applies to nonmetal halogens as well. They increase as you move up the family. So I'm kind of upset that there was a slide in the PowerPoint that's not included in your notes. So really quickly, I'm going to switch over to our PowerPoint. Okay, and I feel like this is kind of important, and I wish you guys could have seen this. Okay, so again, your metals are not always going to switch places with each other. So you have to use this activity series right here. Okay, so if an element is more reactive, so it's going to be higher on our activity series, it will replace the metal that you're trying to switch places with. Okay, so it also applies to your halogen activity series. So your group 7 on the periodic table. So let me pull out my periodic table. Okay, if it decides to work with me. Okay, so on your periodic table, your halogens are all group 7. Okay, so group 7A, these are your halogens. So they're going to follow the same kind of pattern. Fluorine is going to be the highest or the most reactive, and then iodine is going to be the least reactive or lowest. Okay, so when we go back to our PowerPoint, you guys can see that fluorine is going to be the most reactive, iodine is going to be the least. Okay, so let's actually try to do some examples so this can make sense to you. Okay, so can aluminum replace lithium? So remember, aluminum has to be higher than lithium. Okay, so aluminum is right here on our periodic table, but aluminum is not higher than lithium. Lithium is already the highest. So can aluminum replace lithium? No. Okay, so can copper replace gold? Remember, it has to be higher than gold. So copper is right here. So copper, can it replace gold? Yes, because it's higher than gold. Okay, and then barium, is that more reactive than iodine? Can barium replace iodine? Okay, well, barium is right here on our activity series. It's pretty high up there on our activity series. But when we look at iodine, okay, let's take a look. Is iodine here? Iodine's not here, so it's actually a halogen. But barium is high in activity. Okay, iodine is low in reactivity. So can it replace it? Yes, simply because barium has a high activity and iodine has a lower reactivity. Okay, and then lastly, can chlorine replace fluorine? So both of those are halogens. They are in our periodic table. So can chlorine replace fluorine? So is chlorine higher than fluorine? No, it's not. So it cannot replace fluorine. Okay? All right, so I believe that will conclude our notes for this slide right here. So let's go ahead and go back to our notes. Okay, so let me put this down too. Okay, so an important reminder, this is very important. Okay, a metal can only replace another metal or hydrogen. Okay, remember, because like replaces like. So remember that your metals are always the positive element. Okay, and if metal is positive, it can replace another metal. And then hydrogen is also positive, and that's the reason why metals can replace hydrogen as well. Okay, so there are rules again for whether or not your metals can switch places. So our first rule is that metals will replace metals that are higher than them, or sorry, let me make sure, I don't want to tell you wrong. So, okay, see, I knew I was wrong. It's actually metals will replace metals that are lower than themselves. Okay, because remember, one has to be higher than the other. Okay, so let's take a look at our examples. Okay, so if A and B are metals and X represents a negative ion, will the reaction proceed? If yes, what are the products? So A is the metal and B is the metal. So if A is higher than B, are they going to switch places? And the answer is going to be yes, they are going to switch places. Okay, because the metal that's by itself has to be higher than the metal in the compound. So if they're going to switch places, then A is going to be the one with X, and B is now the one that's going to be all by itself. Okay, and then our second example, okay, so is the metal that's by itself higher than the metal in the compound? So in this case, no, it's lower. So this one is going to be no reaction. Okay? All right, so moving on. Okay, so number 1. Okay, using your activity series, predict which reaction will occur. So let's go ahead and pull up our periodic table. So that way we can take a look at our activity series. Okay, so here's our activity series right here. Let's see if I can. This should be good enough. Okay. All right, so number 1. Magnesium plus aluminum chloride. So remember, we're always looking at the metal that's by itself. Okay, so is the metal that's by itself higher than the metal in our compound? So our metal, remember metals are always positive, so they're usually the one that's always first. So is magnesium higher than aluminum? So on our periodic table, you have aluminum right here, and magnesium is above it. So yes, magnesium is higher than aluminum, so a reaction is going to occur. So our products are therefore going to be magnesium chloride and aluminum. Okay, so let's see. Okay, so because we are working on balancing equations as well, let's go ahead and balance this equation right now. So my products, first I have to take care of those. Magnesium has a charge of +2. So let me show you where I'm getting my numbers. Okay, magnesium has a charge of +2. Chlorine has a charge of -1. So crisscross your charges so they can become subscripts. You should have MgCl2 plus Al. Okay, so now I need to balance my coefficients. So magnesium, I have 1 on my reactant side. Magnesium, I have 1 on my product side. Aluminum, 1 on my reactant, 1 on my product. But chlorine, I have 3 on this side and 2 on this side. So I already know that the next number that 3 and 2 are going to have in common is actually going to be 6. So 3 times 2 is going to equal 6 chlorines, and then 3 times 2 again, that's going to equal 6 chlorines. But because I did that, that's going to change the number of magnesiums I have. So now I have 3 magnesiums, so I'm going to put a 3 on my reactant side, and now I have 2 aluminums, so I'm going to put a 2 there too. Okay? Alright, so our next example. We have iron chloride plus copper. So remember, we're always looking at the one that's by itself. So is copper higher than iron? So let's take a look on our activity series. Uh-oh, what happened? Okay, so let's take a look on our activity series. Okay, so is copper is right here, is copper higher than iron? Nope, it's the other way around. So it's going to be no reaction. Okay, let's take a look at the next one. We have sodium plus lithium chloride. So the one that's by itself is sodium. Is sodium higher than lithium? Remember, lithium is the highest reactivity, or the highest reactive metal, so lithium is not going to switch places with sodium. So we're going to have another no reaction. Okay, and then number 4, we have silver nitrate plus zinc. So zinc is the one that's by itself. So is zinc higher than silver? So on our periodic tables, zinc, is it higher than silver, which is at the bottom? Yes. So a reaction is going to occur. What are our products going to be? It's going to be zinc nitrate plus silver. So silver is the one that's going to be all by itself. Okay? All right, so now we're actually going to predict the products from some of the equations that we had up here. So number 1 was a reaction, and silver nitrate was a reaction. Well, to be honest with you, because number 1 and number 1 are the same, and we already balanced it, and we also predicted the products, well, we're going to go ahead and skip number 1 then. But with number 2, we have silver nitrate. So silver nitrate is Ag, and then nitrate is NO3. But remember, we have charges. Silver's charge is a positive 1. Nitrate is a negative 1. So there's no charges that I have to crisscross. And then zinc is Zn. And that's going to yield what? Well, we already know what our products is. We wrote it up here. So zinc nitrate plus silver. So zinc nitrate, Zn, and then nitrate is NO3. Well, zinc has a charge of positive 2, so we're going to need parentheses so we can bring that charge down and become a subscript for nitrate. And then our last one, we have silver. Okay, so that's going to be our products. But now we have to balance our equation. I have 1 silver here, 1 silver here. I have 1 nitrate here, but I have 2 nitrates here. So I'm going to make that become a 2 coefficient. But because I put that 2 there, it changes the amount of silver I have on my product side. I'm going to put a 2 there too. Okay, and then lastly we have zinc. So zinc, we have 1 and 1. Our equation is now balanced. Okay, so number 3. Okay, remember our metal is going to switch places with the metal in the compound. So iron is going to switch places with lead. So our products are going to be Fe, NO3, and let's see, plus lead, because lead is the one that's going to be all by itself now. Okay, so be careful with your charges. NO3, or I'm sorry, let's backtrack. So lead is going to have a charge of positive 2. Nitrate has a charge of negative 1. Okay, but iron, it doesn't really specify what our charge is. So let's see. iron is going to have 2. Okay, so that is actually, now, let me see. We're going to skip that because my key tells me that iron has a positive 2 charge, but just ignore that. So let's actually skip number 3 for now. Okay, so predicting your products is still going to be the same, but as far as balancing, I'm having a hard time explaining that right now, so we'll just skip over number 3 for now. Okay, we'll go ahead and move on to number 2. Rule number 2, any metal that is above hydrogen, so hydrogen, any metal that is above hydrogen will react with an acid to produce a compound plus hydrogen. Okay, and then put a hydrogen at the end of your arrow. So basically it's saying that if you have a metal that reacts with an acid, you're going to have a compound and hydrogen as your products. Okay, so your general form is going to be, let's say you have a metal and then plus your acid. So to know that it's an acid, you're going to have a hydrogen in front of whatever element this is. Okay, so metal plus your acid, and you know it's an acid because there's a hydrogen in front of it. That's going to produce your metal and your negative ion and hydrogen, because remember, your metal is positive and hydrogen is also positive. So if like replaces like, well, your metal is going to switch places with that hydrogen. And if you switch places with hydrogen, hydrogen can't be all by itself. Hydrogen is a diatomic, so it's always going to be H2. Okay, so let's take a look at our activity series again. Okay, so is zinc higher than hydrogen? Okay, so let's see if it'll focus. Okay, so is zinc higher than hydrogen on our activity series? So zinc is right here, hydrogen is right here, zinc is higher, so that's going to be a yes. Okay, next one, we have copper. Is copper higher than hydrogen? Okay, so copper is down here. Hydrogen is above it. So is copper higher than hydrogen? No. Okay, and then last we have calcium and phosphoric acid. Remember that your phosphoric acid, if you have no idea what phosphoric is, well, remember that an acid is always an H and an X. Okay, that's always an acid. Okay, remember X stands for whatever element that is. So that could be your phosphoric. So is calcium higher than hydrogen? Okay, calcium on our activity series is up here. So calcium is in fact higher than hydrogen. So we are going to have a reaction. Okay, and then lastly, okay, predicting our products for metals and acid. So remember, if you don't know what an acid is, just think about your charges. Zinc is positive, hydrogen is positive, and chlorine is negative. So which one is going to switch with which? Zinc is going to switch places with hydrogen. And then we already specified that yes, zinc is higher than chlorine, so a reaction is going to occur. So if we crisscross them and switch them, we're going to have zinc chloride and H2. Remember, H2 is always going to be one of your products. Okay, and then zinc has a charge of positive 2, chlorine has a charge of negative 1, so ZnCl2. Balance our equation. All we have to do is put a 2 right here. So we have 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. Okay, And then lastly, we have calcium and phosphoric acid. So calcium is Ca. Phosphoric acid is H3PO4. Okay, and is that going to, okay, what are our products rather? So remember, calcium is positive, hydrogen is positive. They're the ones that's going to switch places. So it's going to be CaPO4, okay, plus hydrogen, because hydrogen is always going to be a product. Okay, so calcium has a charge of positive 2, so PO4 is going to have a subscript of 2. PO4 has a charge of negative 3, so it's going to be Ca3PO42. Okay, and then to balance my equation, let's start with calcium first. I have 1 here, but 3 here. So I'm going to have a 3 for my coefficient for calcium. Hydrogen. Okay, if you ever have a 3 and a 2, I'm just going to be honest with you, just switch them. So this is going to be 2, this is going to be 3. So now I have 6 hydrogens, 6 hydrogens. PO4, I have 2 PO4s, and I have 2 PO4s here as well. Okay, so that concludes our notes for today. Remember that Rule 2 deals with a metal and an acid, and Rule 1 deals with a metal and a metal compound. Okay, so it's just a regular compound. You're going to have a positive and a negative, or you're going to have a metal and non-metal. Okay, so if something didn't make sense, please ask. If you have any further questions, again, please ask.